Hello again, higher algebra students, back here with lesson 4 from unit 6. This is another transformation unit, but more specifically dealing with reflections this time. So we'll look at same parent functions as we've been looking at, x squared and root of x and absolute value of x, but we'll look at some reflections that occur with these and what the equations will look like, or the functions will look like as we make these, as we execute these reflections. So looking here, if we were to use our graphing calculator or use Desmos, perhaps it would be even easier, or any other app or online source to actually kind of graph 4 versions here of this root x function. This is kind of an intro to how this would look. As you can see, the top left is the original root of x function. The top right, we put a negative out front of that function. In the bottom left, we put a negative inside the radical. And then in the bottom right, we put a negative inside the radical and outside. So what we're looking at here really, if we kind of just look at what the table for each of these would look like, what you're going to find here is for the root of x, if we go to our it's kind of our typical table here for root of x, which would be the 0, 1, 4, 9, we'll keep it at. And again, I'm choosing those numbers because square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So the numbers come out nicely versus using root 2 when you use, approximately 1.41, but the decimal goes on forever. So, so our original graph here for the root of x looks something like this. Again, it was kind of that half parabola coming up from 0, 0, and gradually it had a domain that went from 0 to infinity. The range also goes from 0 to infinity, including 0 in both cases. But again, going off towards the x's much faster than it goes up toward the y's. So that's kind of our original graph. Okay, so now if I were to take the same x values, okay, so I have x, y, and if you were to look at now 0, 1, 4, and 9, and think about what happens when the negative is out front. So for instance, the square root of 4, but a negative out front, you can kind of picture there's these parentheses, that would be a negative 2. Okay, so the square root is still just as we've been looking at it all along. Root of 0 is 0, root of 1 is 1, root of 4 is 2, root of 9 is 3, but the negative is actually applied at the end. So what happens is the 0, 0 remains the same, but if I take the square root of 1, okay, and then I put a negative out in front of that, okay, again, it's like I have parentheses here, that would be equal to a negative 1 or negative 1. And then the square root of 4 is 2, but the negative version of that would be negative 2. The square root of 9 is 3, and the negative version of that would be negative 3, and so on. Okay, so in all these cases, we took the square root as we normally would, and then we put the negative out front at the end. So you can see what ends up happening here as I graph this. I have the point 0, 0, and then I have the point x is 1 and y is negative 1. And then I have the point x is 4, but y is negative 2, and x is 9, but y is negative 3. So you can see this is the same as the black graph that we had over here, except it was reflected over the x-axis. So if I just as a reminder here, this is the x-axis. So having a negative out front, in this case, reflected over the x-axis. Okay. So again, that would be something to consider, to think about here moving forward, that when you make the whole equation negative, as we did here by putting a negative out front, what we're really doing is taking those original y's and flipping them to the opposite value. So if they were negatives to start, they'd go to positive. If the original y was positive, it would go to negative, as happened here between that first black graph and the second red graph. Now, if we look at this third one here, the bottom left, now the negative is inside the radical. Okay, so this we've got to really think about, because with a negative inside the radical, we run into an issue where we can't really put our normal 0, 1, 4, 9 numbers in. Because for instance, if I have x equals 9, then f of 9 here would be the square root, and again, the negative is there, right? That's already in the equation. So that would be the square root of -9. And if you go to your calculator and you type in the square root of -9, you're going to be disappointed when you see that it returns an error value. Okay, again, that's with imaginary numbers. It will say a non-real answer is what your calculator will tell you. So what we have to look at here is how do we combat that? We don't want negatives under the root, but we do know that a negative of a negative brings it back to a positive. Okay, so the way to look at that is we start with 0, but instead of 1, we have -1, because then f of -1 here would be the negative that's part of the equation already, and then for x, we would put in the value of -1. So the f of -1 is the square root of -1, which is just the square root of 1, or 1. So this would be 0 and 1. Okay. Similarly, the square root of -4, but with the negative already built into the equation, in this case would be the square root of a -4. So that's 2, and naturally the square root of -9 there is going to be 3. So we had to put the negative in first because, again, we can only have positive values under the root. So we had to make the x negative to help offset the fact that there's already a negative built into the equation. So keep in mind that negative that's built into the equation is not this negative right here. Okay, it's another negative that's out front, like we saw in these spots when we wrote out the full equation. So in the end, this graph would have a 0, 0 again, but now this second point is a -1, 1. The third point is a -4, 2, and the fourth point is a -9, 3. So what you can see here is instead of reflecting over the x-axis like we did in the top right with the red graph, now we're actually reflecting over the y-axis. Okay, so when the negative is under the radical, like we had in this case, that caused us to reflect over the y-axis. And again, there's a shortcut here of remembering where it reflects, but the other way to check it is to just put them into a table and actually graph this, and you can see from the original, which again was the black graph up in the top left, from the original, what did we do? And you can see from the original down to this one, we have just gone the other direction. Instead of going to the right, we went to the left, which is a reflection over the y-axis. Now you may already be up to feel comfortable with what you're going to see in this last one based on these others, but now we have a negative negative. So what does that mean? Well, first that means we have to again put negative values in for x. And the negative values we put in for x again are trying to offset the negative that's inside. Okay? Once we have done that, then we also have to take a negative at the end. So for instance, if I put in, say, f of -4 here, that would look like this. There's a negative out front, which is the first negative in the equation. Then there's another negative just under the radical, which is the second negative in the equation. But then the value of x here is -4. So we've got the negative out front, but then the -4 is actually negative the square root of 4, which is -2, or just -2. So you can see on the inside, we're doing what we did in the bottom left here. Okay, we're offsetting the negative that's under the radical by making the x a negative value, or 0. And then on the outside, we're doing what we did up with the red, which is at the very end, making our answer negative. So we still had to take the square root of 4 instead of -4, because it had to be a real number. But then at the end, we're making it a negative term. So what we're going to end up with here is the y values for all these are going to end up being negative. As you can see, if we just replace that 4 with a 9, the square root of 9 is 3, and then the -3 is just -3. So that's that pattern would continue. So what we see from the green graph here is the point 0, 0, and then the point -1, -1, which would be down here, and the point -4, -2, which would be right here. And finally, the point -9, -3, which would be right here. So you can see what's happened here is this is a double reflection, okay? Which ends up actually being a 180-degree rotation as well, from the original to the green graph. But what we've really done is when we had the negative on the inside, that rotated, that reflected us again across the y, or over the y-axis. And then when we had the negative on the outside, that reflected us over the x. So in essence, we went from starting right here to going to the reflection over the y with the negative on the inside, and then reflection over the x with the negative on the outside. So that's not a very good drawing there. Okay, so there's really three rules that we have here. We have the negative on the outside, we have the negative on the inside, and then we have the negative on both. And they led to either single reflections over one of the axes or reflections over both axes, which again led to actually a 180-degree rotation as well. And we can talk about orientation. It's basically if we rotate, if we reflect twice, it actually leads to being back to the original shape, and that's where the rotation comes into play. Is it's not backward, because when we reflected once, we went from forward to backward. When we reflected again, we went from backward back to forward, just in a different spot, which is in essence what happened here. Okay, so when we have something like this, now we've got the negative on the inside. Okay, so here, a negative on the inside. In this case, if we put, say, x equals 3 here, then that would be negative 3 squared, which is 9. So what makes this one unusual is there is actually a reflection going on, but you can see what you'll end up seeing is if we were to put negative 3 in for this, f of negative 3, then that would give us negative 3 squared, okay, which is the equivalent of a negative. Again, a negative is just 3, so that's really 3 squared, which is also 9. So what's unique about this is this graph here is actually going to look the same. We have 1 squared is 1, we have 2 squared is 4, we have 3 squared is 9, and on the left side, we have negative 1 squared is 1, negative 2 squared is 4, negative 3 squared is 9. But what actually happened here is there was a reflection that happened. It just so happens the reflection was onto itself. So you can see that what the red half actually started out on the positive side here. Okay, red started out there. Black started out on the negative side over here. But then when we use that negative term, it just reflected it basically right onto itself. So what was the red just went right over onto the black on the other side and became the new red on the left side. What was the black on the left side just got reflected over to the right side. And the reason this happened again is because this is symmetrical across the y-axis line here. Okay, so because it's symmetrical, you don't really tell that we reflected. It's just the left half of the picture is now on the right half, and the right half of the picture is now on the left half. So, so there is a reflection that takes place. Okay, just like we saw last time when we put a negative on the inside. Okay, we can expect to see that reflection. But when we put a negative on the inside before, with the root graph, we were able to see that it reflected over the y because the original graph looked like this. And so the new graph, we saw that it was reflecting over the y and it went like this. Same thing's happening here. It's just that you can't tell because it just reflected onto itself either side. And again, it's simply like this half here is looking in the mirror right there. Okay, and it just saw the other half of the graph. So in the end, when it comes to translations, you do have to remember, keep in mind that translations, again, are this part of a function where you have some addition or subtraction that takes place. Okay, so for instance, if it's on the inside, you see Horizontals on the inside is high, vertical on the outside is vo, so you'll keep seeing this high vo. So if it's on the inside and you add a value, or what would look like adding here, this would actually move left. Okay, so this would translate left. If you see subtraction like we have right here, that actually translates right. Okay, so again, that's because the equation was minus to begin with. So when you see the minus to begin with, that actually makes this one go the opposite. So when you see addition, that means it's actually going back to the left. When you see subtraction, it's moving to the right. When it's on the outside, if you see addition, that means it's translating up. And when you see subtraction, that means it's translating down. So that one's, the up and down's a little easier to see. You just have to keep in mind that because of this negative here, that this first row ends up being kind of backward from what we're used to thinking it would be. Okay. Now, when it comes to the reflections, now again, if it's on the inside, that, as we just saw on the last slide and the slide before that, it's a reflection over or against the y-axis. And when it's on the outside, it's a reflection over the x-axis. Okay, so these are rules that will hold regardless that you can keep in mind. And when we say inside or outside, what we really mean again is on the inside would be like f of x is the square root of negative x. That means the negative is on the inside, or it's negative x squared or something like that. If it's on the outside, that means it's just out in front. So f of x would be negative root x or a negative x squared. Okay, so just understanding that distinction between what is inside and what is outside there is something to keep in mind when you are considering the rules for reflections. So describing transformations here, as we look at these, again, we've got now a negative on the inside, and a negative on the inside, again, is a function that is a reflection over, and again, you could use the chart to help you for now, but a reflection over the y-axis, and or followed by, either way, a translation 10 units down is what's happening here with this one. Similarly, the second one here, now you can see there's this 7 out front, so there's actually a negative on the front of this here, but a 7 that's added. So now this is going to look pretty unusual, but keep in mind that these rules, depending on where the value is, it still makes sense. So so what you're seeing here is I could rewrite this as negative x plus 2 squared and then plus 7. So that might look a little more normal. So keep in mind the negative out front means that this is a reflection over the x-axis. So that's the negative out front. All right. The plus 2 on the inside means that that's a translation 2 units to the left, again, because a plus moves it to the left. Okay, so that's, again, where it's counterintuitive that a plus moves it to the left. And a translation 7 units up. So even though originally the 7 was out front, that's really just a plus 7, and the negative was in front of the x plus 2 squared. So this is a lot, but you're just taking it one piece by one piece. So you got what's on the inside, which is the translation of 2 units to the left. You've got the negative up front, which is the reflection over the x-axis, and you really had a plus 7 there because it's a positive 7, so that's 7 units up. That's pretty involved. That's a pretty difficult question. But again, it's just trying to break down each individual part. So write an equation for the transformation of each function. So we have here the absolute value of x, and we're supposed to have a translation of right 4 units and a vertical reflection. Now, keep in mind, a vertical reflection means that we are reflecting over the x-axis. Okay, so what was this, we now want to have reflected vertically, which means it's going up and down on the reflection as opposed to a left to right reflection, which would be a horizontal reflection or one over the y-axis. So vertical reflection means over the x-axis. Okay, so 4 units to the right, that would mean on the inside of this, we have an x minus 4. Okay, and that's what moves it 4 units to the right, is the minus 4. Now the vertical reflection here, again over the x-axis, means that this turns our y's to be negative. So a reflection over the x-axis puts that negative out front. Okay, so again, you had the choice of putting the negative out front or inside. And in this case, because we wanted that reflection to be vertical or over the x-axis, we want to put that out front along with the minus 4 inside to move that to get that translation 4 units to the right. So as we graph this now, you would have a new graph that is moved 4 units to the right. Okay, so this would be the point, instead of 0, 0 like the original one starts at, this starts at 4, 0. And it's going this direction now. It's going down. So in terms of a domain, the domain is still negative infinity to infinity. Okay, that is still, there's going to be no x. Keep going left and it will keep going right here, even though it's going diagonally. The range, in this case, the minimum of the range, and this feels a little backward, but the minimum of the range is negative infinity now, and it maxes out. Its highest point is when it reaches a y value of 0. So it's a little different than what we've seen. We've done a lot of 0 to infinity, but now we're below the axis. So this one actually it can go down as far, even though it's going diagonal, it's going to reach negative infinity for a y value. I shouldn't say reach it, it'll continue going down negative. So there is no bottom to it, but it does max out at a y value of 0 included here, because the vertex or the top point of this roof, if you will, is at the point 4, 0. Okay, here's another one, graph of the square root of x translated up 7 and a horizontal reflection. Okay, so horizontal reflection again means that we're going to take this from the right side to the left side, which means we want to reflect over the y-axis. Again, horizontal meaning it's going sideways, the reflection is, instead of up and down. Okay, so that means that the negative term goes on the inside now. Okay, so if you go back to that table that we set up, okay, the negative term, in order to reflect over the y-axis, has to go on the inside. Okay, so that would be f of x equals the square root of negative x on the inside, and then translating up 7 units would be adding 7 at the end here. Okay, so there'd be a plus 7 that wouldn't be under the radical. Sorry, I made my radical go a little too far there. Okay, I'll bring this that 7 back over a little bit. Oh, it's not going to be quite as easy as I was wanting it to be, but that plus 7 then, it would look like this. So again, square root of negative x is what causes that horizontal reflection. The plus 7 at the end is what causes that to be a translation up 7 units. Again, this has to be inside, not outside, because outside would make it a vertical reflection or would go over the x-axis and be this one here up on the in the blue here. So this negative 7, negative x under the radical plus 7, if you were to graph that now, would look something like this, where we would be, again, the original was right here, and now we are up here 7 units, So we're at the point 0, 7 where this starts, but going the opposite direction because of that horizontal reflection or that negative x on the inside. So our domain here, again, that's our old graph. This is our new graph now. Our domain actually runs from negative infinity, since the minimum x is way over in this direction, okay? And the max for the domain is the furthest right our graph goes, right? The biggest x it has, and the biggest x it has is actually at 0 inclusive, okay? Now, in terms of the range, you can see the bottom part of the range is actually right there at the 7. So the minimum for the range, I'll make that a little darker color again. The minimum for the range is at 7 inclusive, because it just got translated up 7 units. And the max for the range, as this keeps going up ever so slowly, would be infinity, okay? So you just have to think about what's the floor and what's the ceiling, what's the left wall and what's the right wall. Those sorts of things will help keep straight for you what is the domain and the range for these as we start to get with different graphs and have the minimums be negative infinity and the maximums be the small number of 0 or 1 or 2 or something like that, which is a little different than when we started this. So another reflection, again, here's the parent table function of 0, 0, 1, 1, 4, 2 right here. What we're going to do now is basically we'll change this table here so that we can see the original and the new one. So the original here was at 0, 0, 1, 1, 4, 2, and again it was at 9, 3. So again, there's the original that goes with this table. Now, when we get the new graph in here, again, there's a negative inside. So that negative inside means we are going to reflect over the y-axis or a horizontal reflection. So I can't just put 4 back into there, because if I put this 4 into that equation, well, that would mean that it's negative 4 inside, and you can't take the square root of a negative, okay? So I'm actually, again, going to go to the negative version of these x's. Now I have to think about how it's going to subtract the 3, though. Okay, so this would be 0, 1, 2, and 3, but it said I have a translation of 3 units down then. Okay, so I'm going to just put another here, and now so this is the reflection that occurred here, and now I have to go 3 units down. And 3 units down again means that my y values are going to decrease by 3. So this goes from 0 to negative 3, this goes from 1 to negative 2, this goes from 2 to negative 1, this goes from 3 to 0. So what's happened here is my new graph has the point 0 for x, negative 3 for y. And it's going off to the left now because of that horizontal reflection, but it's down 3 units. So I've got the point 1, or excuse me, negative 1, negative 2, which is right there. I've got the point negative 4, negative 1, and I've got the point negative 9, 0. So you can see here, there's my new graph, which is the same as the black graph, but it's again the reflection because of the negative x, and then the moving down 3 because of the minus 3. And again, put values in to help you with this, and of course Desmos can help as well, but that helps us to see this this reflection, that horizontal reflection, and the 3 units down. So our new domain, it's negative infinity, again, because the bottom of the domain is where's the left wall, and there is no left wall. The top of the domain is where's the right wall. Well, the right wall is at 0. So that's 0. Now for the range, what's the floor and what's the ceiling? Well, the floor is at negative 3. So that's the bottom of the range. The ceiling, again, ever so slowly goes on forever. So that's the top of the range. Okay, so that's our new domain and range, this function that was reflected and translated down. All right, so here's another one. Got a couple things in play here. We've got this negative out front, and we've got a +1 here. Okay, so we've got 2 things we need to consider. the parent function here would have been an f of x equals x squared. So we've added that negative out front, which is a reflection. We've got the plus 1 on the inside, which is a translation. And now here we don't have any restrictions on what can go in our table. So we could just take this table and use the same values if we want to and see what happens. So let's see. So if I put -2 into my equation, so f of -2, again, I've got the negative up front. This value that I'm putting in for x is -2. Now I'm using this. I'm going to add 1, and then I'm going to square it. Well, that means the negative's out front. -2 plus 1 on the inside is -1, and that's squared. -1 squared is 1. So this is -1, or -1. So this value is -1. Okay, I'll do one more up here. What happens when I put in the value of let's say 2 now? Let's put in 1. I'll put in the 1 here. So f of 1 would be the negative out front. 1 goes in for x, plus 1, and then that's squared. Okay, so I've got the negative out front, and I'm supposed to take 2 squared now, because I'm going to do that exponent here first. So that's a -4, or -4. Okay, so this would be a -4. Okay, if I put in a -1, well, then a -1 gets a 0 squared, and that's going to be 0. If I put in a 0, 0 plus 1 is 1. 1 squared is 1. Take the negative of that. If I put in a 2, that means, again, x would be 2 now, so that would be 2 plus 1 is 3. 3 squared is 9. That turns into a -9. So you can see actually what's happening. If I were to keep going in this direction, I'd get that -4, -9 going in that direction as well. So what happened here was this ends up being my vertex. Again, x squared typically looks like this, okay? But now what happened is we had a vertical reflection here, or a reflection over the x-axis. So this is going to be upside down from the original, and it's going to be 1 unit over, 1 unit to the left, because of the plus 1 inside, okay? So we've got -2, -1, and we've got 0, -1. We've got 1, -4, and we would have had -3, -4 if we put that in. We've got 2, -9, and we would have had -4, -9. So what happened here is this graph underwent a vertical reflection over the x-axis. Okay, that's this negative up front. That's why it's upside down. And the plus 1, again, that's backward. So it seems like it might move it 1 to the right, but because the equation is already a minus, it actually moves it 1 to the left. By equation being a minus, I mean the original x minus h plus k. So our domain, what's our left wall? Well, this could keep going, so there is no left wall. What's our right wall? Well, this could keep going out, and so there is no right wall, so that's infinity. Okay. Now our range, again, the low part of our range is what's the floor? Well, this could keep going down, so the floor here is -infinity. But where's the ceiling? The ceiling is at 0, and that's included. So that would be our new ceiling on this one. So again, vertical reflection caused by the negative up front, 1 translation unit to the left caused by the plus 1. Another one here. Again, I've got the negative out front, so if I were to take this table, again, that negative out front is that vertical reflection, and I were to do the same thing to my table here with a 0, -2, -1, 0, 1, and 2, okay, and I put some values in. So if I put in f of -2, that means I'd get negative, and this would be a -2 on the inside. Well, the absolute value of -2 is 2. Okay, so this would be negative, and this would be 2 plus 3. Well, -2 plus 3 is 1. Okay, so this value would be 1. Okay. As we go to -1 here, so f of -1 would be negative, and then again, in the absolute value is -1 plus 3. Well, the absolute value of -1 is 1. So again, we have to take the absolute value first before we do anything with the negatives. So it ends up being negative 1 plus 3, which equals 2. Okay. And 0. If I put 0 into the equation, the absolute value of 0 is 0, negative 0 is 0, 0 plus 3 is 3. If I put 1, now this is where it gets a little unique. If I put 1 into the equation, okay, if I were just to make this 1, that wouldn't change anything there. The absolute value of 1 is 1. The negative up front still makes it a negative, so this goes back to 2. If I put 2 in there, the absolute value of 2 is still 2. Then the negative goes out in front, so it's negative 2 plus 3, which is 1. So you can see what happened here. Okay, our normal absolute value graph looks like this. Okay, it's that V that's going up to the right and up to the left. Well, now the plus 3 moved it up 3 units, so that's the 0, 3 right here. Okay, that's the translation of being moved up 3 units. And then the negative up front caused a vertical reflection. So this V is now upside down. So negative 1, 2, as I just put in these points, negative 2, 1. I put in 0, 3 already, 1, 2 I can put right there, 2, 1 I can put right there. As you can see, if I put 3 into this equation, I'd get to a negative 3, and negative 3 plus 3 is 0. So it looks like this. So there's one, there's the other. So again, the translation up 3 units is why we're up here at the point 0, negative 3, rather than starting at the origin like we usually do. And the negative up front is why we're upside down. All right. So in the end, we have a handful of rules here, and this can kind of be your master sheet for rules that adding or subtracting at the end is what's going to move it up or down. Okay. The plus B is what's going to move it to the left, and the minus B is what's going to move it to the right, or we use H for this as well. Okay. And then the negative out front is the reflection over the x-axis. Okay, so the negative out front is what we call a vertical reflection. So that would again be like this to this. That would be the vertical reflection if we had, in this case, the root of x function. Okay, so that's the negative up front. And if the negative is within, then it's a reflection over the y. So that would be, again, this would be root of x. And if the negative is within, then we reflect over the y-axis, and this is now the square root of negative x. So reflection over the y versus reflection over the x. It's really just getting used to where are those negatives, and that's going to tell you what direction. Is it over the x, which means it's a vertical? Okay, so this would be a vertical. Or is it over the y, which means it's a horizontal reflection? All right. Thank you for those of you who stuck with me through that whole thing. As always, if you have questions, please ask.